Am I audible, please? Just confirm whether I'm audible or not. You can write in the chat box also. Okay, thank you. Hope slide is visible, right? Question number 1. So we'll wait 5 minutes. Maybe another participants will join. Then we'll start. Or you can just read the question number 1 and try to understand the question and try to write your answer also. So that will be the good idea. So in between, you just think about question number 1. So okay, let us start. So question 1. The question 1 is the mirror loss of the minor loss of energy in a long pipe is due to question option A, the sudden contraction, option B, gradual contraction or enlargement, option C, sudden enlargement, option D, all of these. So here Deep is telling option D is correct, all of these. Okay, so other participant, you can also just try to write your answer. Just the question is about the minor loss. So just please try to write your answer for question number 1. Okay, anyone please? Deep is telling option D is correct. Okay, so Ghosh is telling D and Indrajit telling C. Okay, fine. 1 minute. Okay. So Ghosh is telling D option and Indrajit telling C. Okay, fine. So actually here the question is talking about the minor loss. So minor loss are due to the sudden contraction, gradual contraction or enlargement, sudden enlargement, all of this. So all three is the cause of your minor loss in the pipe. So all option will be the correct. So remember please for question number 1. Now let us move on the next question. So here you can see the detailed solution. The minor loss of energy in the long pipe are due to sudden contraction, gradual contraction or enlargement and sudden enlargement. Now question number 2 is what is the aim of pipe network analysis? To determine the mass of fluid, to determine the volume of fluid, to determine the flow rate and pressure drop of fluid. Option D, to determine the cross section of the pipe. So here you have the 4 option. Just think on that. What is the aim of pipe network analysis? So please just try to write your answer in the chat box. I am waiting. Okay, Deep is telling C option, to determine the flow rate and the pressure drop of fluid. Okay. Okay, so Ghosh is also telling C option, right? For question number 2. Okay, so you are telling the option number C is correct. Yes, the main of the pipe network analysis is to determine the flow rate and pressure drop of fluid. So remember, what is written in the detailed solution? The pipe analysis is an analysis that carried out in various aspects. It's mainly concentrates on the fluid through a hydraulic network. The hydraulic networks are networks that contain several interconnected branch. The aim is to determine pressure drop and fluid flow rates. Okay, so very clearly written. Now let us move on the next one. Okay, so here for the pipe connection, for the pipe connected in parallel, the filling the blanks is same for all the pipes. Whether it is head loss will be the same for all pipe, discharge, pressure, friction. If your pipe connected in parallel, pipe connected in the parallel, not in the series, not like that, in the parallel connected. So just try to think how you will, what should be the correct option. Okay, Bose is telling A option, head loss. Head loss will be the same for all pipe. If pipe is connected in the parallel, okay. Anyone please? Head loss, okay. Deep is also telling option A, head loss. Yeah, of course. When your pipe is connected in the parallel, your head loss in all pipe will be the same or equal. So option A is correct. If your pipe is connected in the series, then your discharge will be the same for all. Why? Because as you know, the continuity equation. Continuity equation is what mass in mass flow rate in pipe 1 should be equal to mass flow rate in the pipe 2. If your pipe is like that, so let us, whatever the mass is entering from here, the similar mass, the same mass will enter here, same mass will enter here. So this is the, if the pipe is in series, then your discharge will be the same. When the parallel, your discharge will be what? Here, what will happen? Your discharge will be divided Q1, Q2, Q3, Q4, like that. But head will be the same. If head is here, everywhere head will be the same. In this case, your head will be the different. Head loss, not head loss. Head loss will be the same, similar here, but here will be the difference. And what is the reason? Okay, so we have question on that also, so we'll see. So this is the some basic understanding about your parallel pipe and the series pipe. That concept will help you a lot during the when you will solve the question. Okay. Now, so here you have one numerical, very interesting. Two pipe of diameters 400 mm and 200 mm are each 300-meter long. When the pipe are connected in series, the discharge through pipeline is 0.1 meter cube per second. Find the loss of head incurred. Take friction factor, here it is given 0.0075 for each pipe. Assume head loss due to contraction K is equal to 0.33. So here you need to calculate the total head loss. total head loss due to your friction as well as due to your contraction. So you have to calculate the both, and here you have the two pipe. Okay, just think first you think, then I'll explain how you will solve and how you will approach. So I'll give you for this question 5 minutes please. So you take your time 5 minutes and just try to calculate. This question is very very important you for your exam point of view, NPTEL exam as well as your another your college exam, university exam or gate exam also you can expect such type of question. So please just try to solve. I'll give you 5 minutes. Just please try to calculate. So here the diameter pipe, so both pipe is different, but length is same, discharge is same, and also the friction factor is same. Okay, so let me just explain you. Oh, okay, you can take 1 minute more, then I'll explain you. Very easy question. As we have solved such type of question in the previous week 8 also, but the question was very simple. Find out the head loss only, but here a little bit calculative question because of you have two pipe in series and another head loss you have due to contraction along with friction head loss, so little bit calculative. Okay, so let me just explain you. So here you have the two pipe, one is your 400, another is your 300 mm, like that. This is your 400, this is your 300. Okay, so now the length of both pipe is 300 meter. Okay, now discharge is also given 0.1 meter cube per second. Friction factor is given 0.0075. Another K value is given, contraction 0.33. Now your total head loss is nothing but due to your friction as well as contraction. So now what will be the formula? So for head loss due to your friction, HL F friction factor FL V square by 2ZD. Okay. So head loss in the series pipe, as you know, will be the total head loss in the series pipe HL1, HL2 you need to calculate, and then your H due to the contraction. So this is the unit to apply here. Now HL1, what will be the HL1? HL1 is nothing but 0.0075 into L is given 300. Here you have the velocity. So what is your discharge area into velocity? So velocity will be Q by A, that is Q square by A square. So here you need to put Q square, that is 0.1 square divided by 2 into 9.81 into D. D value is how much? D value you have 400. 0.4 a square. A square is what? Pi by 4. Again 0.4 square to whole square. So after this calculation, what we will get? Okay, so I'll not calculate here. And how we will calculate the HL2? So similarly for HL2, your diameter only here you need to change. So at the place of 0.4, at this place and at this place, you need to put 0.2. So you will calculate very easily HL2. Now, what will be the formula for K contraction? So as you know, for the contraction factor, you know the velocity is nothing but your your head loss v square by 2g, but in the question contraction is given. If in the question contraction is given, so you need to follow this. That is, you have to multiply with the factor, contraction factor, v square by 2z, and sum your factor, contraction factor. So now, as you can see here, I'll just show you the calculation part. So here you can see very easily your in pipe 1, that is 0.4, your value is coming 0.1816 meter. Now due to the contraction it is coming 0.17. In pipe 2 is how much? In pipe 2, after putting 0.2, so you are getting 5.08, 5.809. So summation, because why we are doing summation here, as you know, pipe in series. So after summation, pipe 1, this is your contraction K, and this is your pipe 2. So you will get 6.16. So here your option, which option is correct? Option B is correct for question number 4. So hope you all understand. Okay, so now let us move on the next one. Next question is question number 5. The head loss at the entrance of pipe is that at its exit. So just please try to think what question is asking and try to write your answer in the chat box. So I'm waiting. Whether it is equal to half, twice, and 4 times. The head loss at the entrance of pipe is that at its exit. So what should be the correct one? So please anyone just try to write your answer in the chat box. I'm waiting. You have another 1 minute, then after I'll show you the answer. Okay, half. Deep is telling half. Okay, fine. Other student, please. Okay, B is telling means you are also telling the half. Okay, so fine, let me just show you the answer. So here the question is asking about the head loss at the entrance of the pipe means if this is your pipe, this is entrance or this is exit. So head loss at the entrance and head loss at the exit, the relation between actually these two. So HE or HEN I'll write here, entrance or EX exit. Okay, so how these two uh, have the relation? So let us write the formula for your entrance. So H entrance and H EX formula. So now I'll show you. Here you can see very clearly your HI and HO means HI here is your entrance and HO is your exit. So that is 0.5 means 0.5 times of V square by 2Z, or you can write half V square by 2Z, and this is your V square by 2Z means here you can say very clearly your head loss at entrance will be less than head loss at exit. So if you are going to design something pipe, so what you will think? You will think like that at your exit your head loss will be the more. So you will focus more how to reduce the exit head loss rather than your inlet, because anyway it is half of your, here you can see very clearly this is, you can write HEN is equal to half and V square by 2Z is nothing but HEX. So means HEN is half of HEX. So here option is B. So you all correct. Now we'll move on the next one. Question number 6. So question 6 is, in a pipe network, the algebraic sum of, here we need to fill the head loss, discharge, pressure and the friction around each elementary circuit is 0. So which one? Whether your head loss will be the 0 around each elementary circuit, discharge, pressure or friction. You have four options here. So please just think on that and then try to write your answer in the chat box. Very easy question. Yes, easy means when you have follow the NPTEL lectures and all, then it will be easy. Otherwise, these are some technical questions, so that will be very difficult. Okay, so Ghosh is telling A option, nice. Head loss. Other student, please. Easy question, not very difficult. You have pipe network and you are doing algebraic sum, and you have one elementary circuit. So if you are summing discharge, pressure, friction and head loss, what will be the zero? Actually, this is one of the your condition for solving the your network. So just think on that. Okay, so let me just show you the answer. Okay, so Deep is telling the algebraic sum of head loss around any closed loop is zero. Okay, nice. So yes, so it is correct. So head loss will be the zero. Here it is in the detailed solution also written. The algebraic sum of head loss around each loop must be zero. This is your one condition for solving the equation, your pipe network. So what is pipe network? This is your main pipe, then it is go in the some branches, then it is meet another pipe, then it is go some different. So like that. So this is one loop. Okay, so now I'll explain. Okay, now we'll go on the next question. Very important question. So here you have question number 7. The chart showing the variation of friction factor. Remember please, with Reynolds number Re and silent by D is called diagram. Which diagram or which chart? Colebrook, Moody, Seals or Euler? Which one? Very easy question. Actually, when I was discussing, I think week 7, that time I was discussing the same thing. So you hope you have remember, then very easily you can give the answer. You have one chart which have the your relation between friction factor, Reynolds number, and silent by D. Deep is telling Moody chart, okay, or Moody diagram. Other student, please also you can just try to think on that, which options would be correct. Another 1 minute I'll wait, then I'll show you the answer. Okay, so let me just show you. So here your diagram, such type of chart you will see in your fluid mechanics book, like that. Here is epsilon by D, then here your Reynolds number, then your F. In the laminar flow, it is like that, then it is, the diagram is like that. Hope you able to relate. So like that. After some Reynolds number means, after getting a Reynolds number, or after the, let us suppose here Reynolds number is X. So after X Reynolds number, your the variation of the friction factor is negligible. It is not like that. This is not correct. So okay, this chart is known as your Moody chart. Remember, please. Okay. Now we'll move on the next question. So here you have the average flow velocity in a horizontal pipe is u due to sudden enlargement. Means your pipe is going like that, and due to sudden enlargement like that. Due to sudden enlargement of the pipe diameter, the flow velocity changed to v. Means u2 here was u, and then it is changed v. The head loss due to sudden enlargement is equal to. So head is due to the sudden enlargement, head loss. So what will be the correct formula? Whether u minus v whole square by 2z, option A. Option B, v minus u whole square by 2z. Option C, u plus v whole square by 2z. Option D, u minus v whole square by z. So here you have the four options. Just try to write your answer, please, for question number 8. Very easy question. Okay. Gauss is telling A option, that is capital U minus capital V whole square by 2z. Nice. Other student, please also just try to write your answer in the chat box for this question. Okay, so just let me just show you. So this is for sudden enlargement. Your head loss your initial velocity, that is definitely here velocity will be the more, your u will be the more than v, so more minus less, just for remember, whole square by 2z. Okay, so now let us move on the next one. Question number 9. So at the junction of any pipe network, the flow must satisfy the Bernoulli equation, continuity equation, Navier-Stokes equation, none of this. So which option will be correct for question number 9? Okay, according to sudden contraction formula, v square by 2z due to change in velocity formula. Okay, okay, nice. So Deep was also okay. So for question number 9, Deep is telling B option. Continuity equation should be satisfied, must be satisfied actually. Okay, other student please also just try to write your answer in the chat box. Other student please also just think on that about this question. Very easy question, not if you will think very well, definitely you are able to give the answer. Just think on that, please. Okay, so let me just show you the answer. So definitely continuity equation should be or must be uh, it must be follow at the junction of the pipe network. Remember please your continuity equation. Next, the detailed solution at the junction, the algebraic sum of the flow rate together with an external flow is 0. Okay, so next one, question number 10. Okay, so question 10 is, which property of fluid accounts for major loss in pipes? Density, specific gravity, viscosity, compressibility. Major loss. For question number 10, please just try to write your answer. A little bit, you have to think about the question first. Just think, then correlate the things, then you will definitely able to give the answer. Which properties of fluid account for the major loss in pipe? Just read the question and try to understand what question is asking and what question is telling. So one thing remember please, before giving your answer, first try to read very well the question. Okay, so Ghost is telling C option. Okay, nice. Other student please. I'll wait 1 minute more. Okay, viscosity. Deep is telling viscosity. Nice. So question is asking about fluid properties. So remember please, one thing is very very important here. In the loss of our head loss in pipe is, this is your friction. Let us, the pipe friction is like that. So this is your pipe characteristics. Now within the pipe your fluid is flowing. If fluid is flowing, so what happened? The fluid property also, some fluid property also responsible for this loss, major loss. So which is your fluid have, the fluid property is what? Fluid property density, fluid property is, this is your fluid property will be the your specific, or you can say the unit weight, and also you can say the viscosity, compressibility. These are the fluid properties. So out of this your viscosity is responsible for that, the major loss. How? Let me explain you very well how it is, or let me just read, then I'll explain you. Detailed solution: the major loss of flow through pipe is due to frictional resistance between adjacent fluid layers sliding over each other. What is the meaning? I'll explain you with figure. The resistance arises due to the presence of viscous property of the fluid. Meaning, let me just draw the pipe, and as you know the pipe is, you have the friction, so boundary layer will be the develop. And also let us assume your fluid is flowing in the parallel, very parallel to each other, like that. So what will happen at the your boundary, your no slip condition will be, no slip condition phenomena will be happen, because here your fluid will be the zero, velocity at the wall will be the zero, then slightly it will be more, slightly more. Let us, I'll draw here, here will be the zero, slightly more. Then this fluid is, the velocity of this is, let us suppose v1, velocity of this is v2, so v1 will be the less, v1 is less than v2. So what will happen is v2, your v1 try to reduce the v2 velocity. So it will be like that. It will be like that. After that, getting the maximum, then similarly from this side also. So if I draw very clearly, after fully development length, your, the diagram of velocity will be the parabolic. So if I show you here, so your velocity in the laminar flow will be, in pipe flow, look like that. If your, this is your velocity and this is your flow depth, then Here is 0, then increasing, 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 increasing. After that, after certain time, you will able to see your velocity is like that. That is, variation is very very less, because the the effect of this wall or effect of these low velocities is getting it reducing as you are moving in upward direction, and as you are moving in from your bed level, or you say the wall, from wall to middle range. So hope you understand. So now we'll move on the next one. So the answer for this question is question number 10, your viscosity. Now the next is your 2024. Okay, so here answer is visible. So just think on that, how it is, how this answer is correct. Option B, how it is correct, and how, what is the question. So I'll take here 5 minute break, please. If you want, you can also take. So just think about the question and try to think how option B is correct for question number 1. Anyway, I'll explain. So, okay, so I'll take 5 minute break, please. Okay, so let us start. So question one here is, let me just take the pen. In network of pipe, the head loss in all circuit is same. The head loss around each elementary circuit must be zero. The elementary circuit are replaced by equivalent pipe, none of the above. So as you know, already we have discussed in the previous one. So head loss around each elementary circuit must be zero. The similar question, only the language is different. Okay, so let us move on the next one. So here some explanation also written. The basic pipe network analysis consider that the head loss around each elementary circuit is zero. Okay, so now we'll move on the next one. Question number 2. When the pipes are connected in parallel, the head loss is equal to the inverse of sum of the head in each pipe is equal to the sum of loss of head in each pipe is same in each pipe is half that in each pipe. So just try to write your answer in the chat box, please. Okay, so option C you are telling is same in each pipe. Yes, definitely we have discussed this question in the previous one also, so we'll not waste time here, so we'll move further. So yes, definitely your option C will be correct here. So now we'll move on the next one. 3. Okay, so which of the following relation may be used to replace a pipe diameter d by in parallel pipe of the diameter small d? Parallel pipe. So option A, d is equal to nd, small d is equal to n capital D. So similarly option B, C and D you can just see. Just try to think on that and try to calculate, please. Which of the following relation may be used to replace the pipe diameter d by n parallel pipe of diameter n? You have one pipe like that, one pipe of diameter d you have like that, capital D. Now you need to replace this pipe with the multiple parallel pipe with a small d. So how you will, just try to think how you will come up with this relation with your the bigger one to a smaller one, how you will move. Another thing, you need to arrange this pipe in the parallel. Okay, so just try to think for question number 3. Okay, for previous question, you both were telling deep and goes is C. But for question number 3, just try to write your answer, please. Interesting question, please. Okay, another 1 minute I'll give you, then I'll show you the answer. Okay, so just let me show you. So here you have just I have explained you have one, bigger pipe, and you need to convert this pipe in a multiple pipe with smaller diameter. So how we will proceed? So for this, you know already in the parallel pipe what you will do. In parallel pipe, your discharge Q is equal to, that is your bigger one, will be the Q1 plus Q2 plus Q3, like that. So based on your how you will distribute this discharge, so you will get the this number of pipe. Okay, so here the detailed solution is given. Let us just, I'll just explain you. So for parallel pipe system, the continuity equation is given by, that is Q is equal to Q1 to Q1. So that is nothing but your area into velocity is equal to N is area into velocity. Here assumption is, here assumption, remember please, all Q, that is all diameter, all pipe diameter is similar, means D, D, D. So if the diameter is similar, definitely your Q will be the similar. So if it is 3, so definitely it's 3Q, means N value will be the 3. But here this is not a numeric type question, so the relation here you need to find out. So now your d square, d, that is pi by 4, will be the cancel out pi by 4, only you will come up with d square v by n d square u. Means what you are doing here, the capital D discharge is equal to a small d discharge, nothing, just discharge, you are balancing the discharge, the continued equation. So now just both side square, then v square is equal to nothing but n square d4 d to the power 4 u square d to the power 4 here. Now here you know one thing, your head loss will be the, in your bigger pipe and your smaller pipe will be the same, as here you can see very clearly. That is where v is your velocity of the original pipe and u is the velocity of a smaller pipe, but the head loss for the main pipe and the smaller pipe must be same. So the condition here it is written. So now here the relation is very easy. So v square by d, that is FL2Z will be the cancel out, means you are assuming here the length also we are considering the same as the bigger was. So here n square, so you can put very easily v square value, that is n square d to the power 4 u square d to the power 5, because already d here is, and u square is value is d to the power 4. Now u square by d. So from here you can very easily calculate the d to the power 5 is equal to, because this is 4, once you will go this side, d to the power 5 is equal to d to the power 5 n square, and d is equal to nothing but d is equal to like that. Let me just show you the simple, d to the power 5 n square, means d is equal to nothing but d to the power 5 and 5 by 5 and 2 by 5, so definitely 0.4. So option D is correct here. So hope you understand. This was the way of calculation how I will proceed such type of question. Now we'll move on the next one. Question number 4. So question 4 is total energy line lies over hydraulic gradient line by an amount equal to velocity head, pressure head, sum of velocity and pressure head, none of the above. Just please try to write your answer in the chat box. Total energy line. Okay, velocity head. Deep is telling velocity head. Okay. Other student, please. Nice. Velocity head. Other student, please also just try to think and write your answer in the chat box. I'll give 1 minute, then I'll explain you. Okay, so just let me explain you. So let us assume you have one pipe like that, and water is flowing from this direction to here. Now you have just your velocity hydraulic gradient line is nothing but you just insert here your one piezometer. Here also you need to insert. Here also. So what you will see, the head is here, then head is like that, then head is like that. So this is nothing but your HGL, that is hydraulic gradient line. Hydraulic gradient line. Now, once we will add in this hydraulic gradient line your velocity head v square by 2z, and this line will be become your energy gradient line. Energy gradient line. So hope you understand the things. So definitely your total energy line lies over the hydraulic gradient line by an amount of v square by 2z. Hope you understand. Now we'll move on the next one. Next question. Question number 5. So here some explanation is given. Let me just read for you. The hydraulic gradient line is the line joining the piezometric head. These are the piezometric head. The sum of pressure and datum head. Remember please, these head is also important. Sometimes the question directly asks the piezometric head is the combination of what? Whether it is velocity head, pressure head, datum head. So like that, the combination of all these three. So definitely your piezometric head is pressure head and datum head at various point in the flow along the length of the pipe with respect to some reference line, whereas total energy line is the line joining the total head, that is your sum of all three head, pressure, kinetic and the datum at various point in the flow along the length of the pipe with respect to some reference line. So always remember. So now let us move on to question number 5, which is about the hydraulic gradient line again. For a flow through a pipe is always below the total energy line, above the total energy line, above the axis of the pipe, none of the above. Just please think. Yes, definitely below the total energy line. Okay, definitely, as we have discussed here in the previous question, so I'll not waste time here. So as I have discussed here, as you can see very clearly, your definitely this is your below the your energy gradient line. Why? Because of explain already I have explained you. So now let us move on the next one, question number 6. Question number 6 is the total head at entrance. Remember please, total head at entrance of the pipe in terms of mean velocity of liquid V in the pipe is 0.5 V square by 2Z, V square by 2G, V square by Z and 0.2 V square by 2Z. Here question is asking about entrance, not exit. So just think on that, and whether entrance is more or exit is more, you have to consider. Okay, so you are telling A option 0.5 V square by 2Z. Okay, other student please also just write your answer as we have discussed in the I think the first question or second question what we were solving today. So the about only the your entrance and exit loss, that is a minor loss in the pipe. Similar, just think on that. And that time formula I was also discussing. So hope you need to remember the things. Okay, Ghosh is also telling A option. Nice. Okay, definitely. Your at the entrance, your the head loss will be the less compared to an exit. So that is at entrance your half V square by 2Z, and at exit your V square by 2Z. So definitely your these things remember, then you will never forget the formula. Your exit will be the more than inlet. Okay, so now we'll move on the next one. Okay, next question is the loss of head at exit. Now the question is exit of the pipe in terms of mean velocity V at the pipe outlet is given by. So please just write your answer in the chat box. Very easy. So just I want to see your answer in the chat box as I have explained also. So just I want to see. Just type, just write your answer please. Okay, B, both you are telling the B option. Nice. That is V square by 2Z. Yes, we have already I have discussed. So here we nothing need to discuss here. Here you can see very easily. Sorry. Here I have discussed already. So okay, so now we'll move on the next question. Next question is a pipe is said to be equivalent to another pipe if the length and discharge are same, the length and diameter are same, velocity and diameter are same, discharge and head loss are same. So here you have the four options. The question is asking about equivalent pipe. equivalent to another pipe. Means as we were solving in the previous one, so similar thing, just think on that. What will be the hmm? What? So please just try to, okay, you are telling the D option. Okay, nice. Okay, so D option. You both are telling the D option. For discharge and the head laws are same. Okay. Yes, definitely. D option is correct here. So detailed solution is a pipe of uniform diameter having loss of head and discharge equal to the loss of head and discharge of a compound pipe made by several pipe of different diameter, as we have solved in the previously, like your from bigger one to a smaller pipe. So what you will do, discharge is equal to n of discharge, that is capital due to a small d, but the condition here is the length of all small pipes should be the same, length of equal, and your diameter also of the all pipes should be the equal, then you can write this relation. Otherwise we have to go with the your concept of your parallel pipe and the series pipe. So now we'll move on the next one, question number 9. Question 9 is the Darcy's Weisbach equation is used to find loss of head due to sudden enlargement, sudden contraction, friction, none of the above. So Darcy's Weisbach equation is used to find loss of head due to, just think on that, sudden, okay, just please you write your answer, then I'll explain you. Okay, so for question number 28, you are telling option C is correct. Okay. Yes, definitely. As we have discussed a lot about it. The Darcy's Weisbach friction equation is nothing but your HF is equal to your friction factor LV square by 2ZD. Remember please, this is your friction factor, not friction coefficient. If that will be the friction coefficient, that is the 4 friction coefficient LV square by 2GD. Yes, definitely your Darcy's Weisbach due to the your friction. Now we'll move on the next one. Question number 10. The energy loss in pipeline is due to surface roughness only, viscous action only, friction offered by pipe as well as viscous action, none of this, none of the above. So just please think, your energy loss in pipeline is due to what? Whether it is roughness, viscous, friction offered by pipe as well as viscous action, none of this. Okay, so Deep is telling C and Ghosh is also telling C. So because yes, definitely it will be the correct, because as we have seen also, your visc fluid properties as well as your pipe properties both are responsible for your friction factor. Like if you have one pipe, so the pipe quality, that is pipe roughness, whether it is like that or whether your pipe roughness is like that, this is your entry, this is your exit, so whether it is roughness is like that, so I'm showing you in the zoom view, remember please, roughness should not never look like that. So in the zoomed view I'm just trying to show you, so whether it is roughness is like that, definitely depend. Again, whether the fluid viscosity is also responsible, whether you're within the pipe your oil is flowing or water is, or any liquid or fluid also, that is your air also, so it's depend on both. the detailed solution, what it is written, let me just read. The friction factor in the Darcy-Weisbach equation takes into account both surface roughness of the pipe material as well as viscous resistance, computing the head loss. Okay, no issue. The similar thing. Next, entrance length is the entrance length is option A, the length in which the boundary layer remain uniform, the pipe length inside the reservoir, the length of pipe from its entrance in which the flow may be assumed irrotational. Option D, the initial length in which the flow develops fully such that the velocity profile does not change downstream. So here you have the four option. So just try to write your answer please for question number 11. Very easy question as I have discussed many times. So just read first very carefully one by one each option, then you just think on that. Very easy question. Okay, Ghost is telling option D is correct. Nice. Other student, please also just try to think and write your answer in the chat box. Okay, Deep is also telling D. Yes, definitely D is the correct option for this question. How? Let me just explain you how it will look like. So let us assume this is your pipe, water is flowing. Okay. So as you know, due to the your viscosity of the fluid as well as your roughness of the pipe, boundary layer will be the developed like that from this wall 1 and wall 2. So it will be like that. After a certain distance, after reaching a certain distance, the boundary layer will be the merge, and after that there is no such reason in the after that. So what will up to this, the length is known as your entrance length. This is your entrance length. So this entrance length have some formulas for laminar as well as for turbulent. Previously also I have recommended you just follow some standard book of fluid mechanics, or you can just type on the Google, you will find out this relation for pipe flow. So what will be the entrance length for your laminar and for turbulent? For laminar case, your velocity distribution will be the like that, parabolic. Velocity distribution parabolic. If it is turbulent, your velocity distribution will be here it is linear linear, then it is logarithmic. Up to here linear, then logarithmic. So remember please. So for laminar case, it is parabolic. For turbulent, it is logarithmic, mostly logarithmic. Okay, so now we'll move on the next one. In the detailed solution, what written? The length over which the flow evolve into a fully developed state is called entrance length. Okay, the similar thing. Now the next question, question number 12. The head loss in a sudden expansion from 6 centimeter diameter pipe to 12 centimeter diameter pipe in terms of velocity v1 in the 6 centimeter pipe is option A, B, C, D. Option A is 15 by 16 v1 square by 2z. Option B 3 by 4 v1 square by 2z. Option C 1 by 4 v1 square by 2z. Option D 9 by 16 v1 square by 2z. So please just try to calculate. Very easy question. Just try to calculate please. Question number 12. You have another 2-3 minutes you have, or 5 minutes you can also take. So please just try to calculate. Just please think on that. Okay, so 9 by 16 V square by 2Z means you are telling option 9 by 16 D option you are telling. Okay. Okay, so let me just show you. So here your formula is for sudden loss means you have one pipe of 6 centimeter, then another expansion, sudden expansion like that. That is, this was your 6 centimeter diameter and this was your 12 centimeter diameter. So what will happen? And velocity v1, this is your velocity v1. So you need to write the your head loss formula in terms of v1. So you have, so what is your loss? So loss is entrance v1 minus v2 whole square divided by 2g, as we have discussed in the previous questions also. Now, so as you know, the continuity should be follow here, that is a1 v1 is equal to a2 v2. So what is your a1? A1 you know, pi by 4 d square. So pi by, that is pi by 4 will be cancel out. So pi by 4 into 0.06 square v1 is equal to pi by 4 0.12 square in v2. So here you can say at the place of square it is written 2 times. Very easy. So now your v2 is equal to, after calculation you will get 0.25 v1. So now here you need to put, so that is 0.25 v1. So once you will minus v1 minus 0.25 v1, you will get 0.75 v1 whole square. Then after 0.75 square is nothing, square by, and you by divide by 2 is your 9 by 16. So you will get this part after the calculation. So 9 by 16. So very easy, you have to just apply two condition here. One is your continuity equation you have, and another you need to remember the formula. That's it. So now we have another set also for your the question. I think this is assignment number, this assignment from your 2023. The previous one was 2024, and yeah, and the first assignment was 2025. So now here, what is the formula for determining the size of equivalent pipe for two pipe of length L1, L2 and diameter D1, D2 respectively, where L is equal to L1, L2. So as we were discussing in the previous questions, the length was same, diameter was same, but here you not have the similar your length and the diameter. So what should be the formula? Formula is nothing. Your D is equal, or that is your option D is correct here. That is L by capital D is equal to L1 by D1 plus L2 by D2. How? Let me just show you the solution part. So this is the relation here. Dupit's formula for equivalent pipe is L by d to the power 5 is equal to L1 d to the power 5 and all. So this is nothing but your discharge. Nothing. Discharge is equal to Q1 plus Q2 plus Q3, like that. Another, your one thing also you can write here, that is your head loss. For the formula for determining the size of equivalent pipe of two pipe L1 and L2 and diameter D1 and D2 where L1 and L2 all. Okay, so this is question is asking your about I think. Okay, so if you will do this, also you need the formula for your head loss also, remember please. So head loss formula is also very very important here, because you find out the discharge in terms of, you convert discharge in terms of your head loss, that is your FLV square by 2ZD. So from here you will get the discharge. So like that, once you will put, you will get the final equation like that. Okay, so now question number two. Question number two is here, uh, two pipe line of equal length of diameter, uh, two pipe of equal length and diameter of 20 centimeter and 30 centimeter are connected in parallel between two reservoirs. If the friction factor F is same for both pipe, the ratio of discharge in the large to a smaller pipe is. So here you need to calculate discharge in the large pipe, discharge in the smaller pipe ratio you need to calculate. So how you will calculate? Just think and try to calculate within 2-3 minutes. Question number two. Just please try to calculate for question number two. Okay, anyone please? Pipe are connected in the parallel. So here one thing is, remember please, if pipe in the parallel, your head loss will be the equal in the both pipe. So just equate the thing, that is your head loss in one pipe is equal to head loss in two pipe, and definitely in one pipe is smaller than another pipe, that is 20 centimeter and 30 centimeter diameter. So here very easily you can calculate. Just think on that what I am trying to explain you. It's very easy. Okay, so let me just show you. So in the parallel, question is telling in the parallel. So in the parallel pipe, you know your head loss in one, that is smaller one, in head loss in the larger one. So length is same, so L will be the cancel out. F will be the cancel out. Only your diameter, that is area, that is your velocity, by D. This side also your velocity by D. This is for a smaller, this is for bigger, large. So this is the relation. Now your discharge is nothing but your velocity is what? Discharge by area. So at V square, so here will be the V square. So this is your Q square by A square D smaller is equal to Q square by D D large. Now in the question, just please you have to, this is your smaller and this is your bigger. So smaller to bigger you need to calculate, or large to, in the question is large to smaller. So this is your large. So Q large divided by Q smaller whole square is equal to nothing but your pi by 4 d square will be the cancel out. A square is nothing but pi by 4 d square. So that is d to the power 4. So you will get d to the power 5 here, d to the power 5 here. So I'll remove this from here. Pi by 4 will be cancelled out anyway. So d to the power large 5 d to the power small 5. Now your ratio will be 30. Oh, let me just write here. Q large by Q small is equal to 30 divided by your D is 20, smaller d. Already power 5 is there, and once you will, this power will go that side, that is right side, divide by 2, that is 2.5. So after the calculation you will get 32. Option A is okay. So here is 32 is coming, and the correct answer is 2.75. Or let me just correct you, let me just solve you. 3 by 2 power 2.5 means 1.5 power 2.5. So means, yes, I think option C will be correct. Let me just check the calculator, because it seems like 1.5 power 2.5. Yes, 2.5. It's your option C will be correct here. 2.75, not. Okay. So option C is correct. Next question is, what is the aim of pipe network analysis? So I'll not read the again. This is we have already solved. Option C was correct, to determine the flow rate and the pressure drop. Okay, so what are the assumptions made for the fluid through a pipe? Fluid inertia is not taken, viscosity is not taken, volume is not considered, mass is not considered. So what are the assumptions made for the fluid flow through a pipe? This is the new question. So please just think on that. What will be the correct one? Okay. For the previous question, Deep is telling C. Nice. For this question, what will be the correct one? Okay, so let me just show you the answer. We not have time. So what are the assumptions made for the fluid flow through a pipe is fluid inertia is not taken. Means during the during a fluid flow through a pipe, there are various design consideration, but the two major assumptions are that the flow assumed to be fully developed. Also, the fluid inertia is not taken into account. Next question. Here we know already the liquid flowing through a series of pipe can be taken up pipe of different diameter, pipe of same diameter only, single pipe only, short pipe only. No, pipe of different diameter possible. No issue. Yes, so here total head loss for the system is equal to what? Total head loss for the system is equal to pipe length, pipe diameter, width of reservoir or height difference of the reservoir. Just I want to know from your side for question number 6, please. For question number 6, which option will be correct? For question number 6, total head loss. Yes, definitely option D will be correct. It's a high difference of reservoirs. Next question is question number 7. What is the loss loss develop in a series pipe? Sum of loss of each pipe only, sum of local loss only, sum of local losses plus loss in each pipe, or zero. So definitely C option will be correct. Sum of local losses plus the loss in each pipe. In parallel pipe, the all loss will be equal, but in the series not like that. Okay, so this question we have already discussed lot. The coefficient of friction of a laminar flow is option C will be correct, 16 by Re. Coefficient of your friction coefficient is equal to 16 by Re, or what will be the your friction factor? Friction factor is 16.4 by Re. Now we'll move on the next one. Question number 9. The minor losses may become dominated for the pipe of large, small, return bend and flange. So definitely a small. For a small length of the pipe, your minor losses may become the dominant of the pipe. Remember please. This is very important question. Next one. In pipe network, your the algebraic sum of distance around each elementary circuit. Okay, we have solved this question already. The algebraic sum of piezometric head drop or head loss around each elementary circuit is 0. This question we have already solved. Question number 11. For laminar flow through a circular pipe, the maximum velocity is 2 times. Already we have discussed, I have discussed a lot of times this is relation. If the pipe, if your plate is like that, parallel plate, and water is flowing, so U max is equal to 1.5 times of your U average. But in the pipe, it is 2 times. Remember please. So option B is correct here for question number 11. So this is the last question for today. How do we determine the total discharge through a parallel pipe? Add them, subtract them, multiply them, divide them. Very easy, definitely will add. So these are the questions we have seen many times today. So now, okay. Okay, so thank you for today. So we'll meet again, I think on the 29. We'll meet again on 29 March. So thank you for today's session. Thank you all. Now, okay, thank you, Dev.